What is up, guys? Welcome back. Today I want to take a look at how we can make this animation. It's kind of a paint reveal animation by using the Canvas API. And I'm also going to use React to remake this. And it should look something like this, the live demo. Kind of a nice painting animation, really smooth on mouse. And it creates this nice effect. And by learning this, you actually learn also the building blocks to eventually create something more fancy like this animation right here, which also uses the Canvas API. So one thing that this animation uses that's really interesting is the Lerp. So we're going to take a look at how we can make this. And as always, you can find the live demo here and the source code both in the description below. Alright guys, so I have a very basic Next.js application here, and I've already created a text component and a scene component. Inside of the text component, nothing too fancy, just the text that we see here. And inside of the scene, that's where we're going to create the Canvas API. And I've already created my canvas with a div inside of it. And I'm also using a hook that I've just created, a use window hook that basically takes the size of the window and returns it. And also if we resize the window, it's going to adjust those values. And I need that hook because the canvas requires the height and the width as parameter to get like initialized. And so that's why I'm using my use window hook here. So if I look at the demo here, the first thing that I want to do is to black out my screen. So right now I have my layout, and what I want to have is the canvas on top of it. And then I want to create like a black rectangle on top of everything else. So to do that, I'm just going to have a use effect hook here that's going to be running every time the dimension of the window changes. And so in the beginning, the dimension here is initialized at 0, 0, right? And then when the component mounts, that's when we set the dimension. So the first render, we actually won't have the size of the window available to us. So here in the use effect, we need to check if the dimension of the window, for example, the width, is bigger than 0. And here we can have an init function. And that's really important because before we start making something using the canvas, we want to make sure that it's initialized properly. And now to black out my screen, I need to have access to my canvas to get access to its context. So for that, I can just create a reference to it, and then I'll be able to target it. So I'm going to have my reference to my canvas, for example. And then I could have here const canvas is equal to a useRef hook. And so now I'm putting the reference to the canvas inside of that ref, and I can grab that canvas and extract the context from it. And here I can do canvas.current. And then here I'm going to specify that I want to get the 2D context of the canvas, because we can also do 3D using the Canvas API. But for now, I'm just going to grab the 2D. And here, like I said, I want to black out my screen. So I'm going to do context.fillStyle. And here I can specify I want my fill style to be black. And then to draw a rectangle on the whole screen, I can use this function called context.fillRect. And here it's going to basically fill a rectangle with the fill style that we specified. And it needs a couple of parameters. Here we can see x, y, the width and the height. So x0, y0. So it's going to be at the top left corner right here. And then to have a proper rectangle that takes the full screen, I'm just going to give it the dimension.width and dimension.height. And again, those values come from this little hook that I made, which takes the dimensions of the window and put it inside of a state. And I can save that. And you'll see that now my screen is blacked out. And if you have a good eye, you're going to see that on the first render, there's actually a flash, right? We kind of see the layout first and then it gets blacked out. And that's because the width and the height here are initialized at 0 at first. And so the first render, I don't have access to the dimension of the window. And that's why we have this flash of style. And so what we need to do to not have this, because it's quite annoying, is we can simply have a div here. And I'm going to put it width full. So taking the full height and the full width, so width full and height full, and a background black. And if I save that, I should have something like this. Now I'm going to put it also in position absolute, so that way it's stacked on top of the canvas. I'm going to save that. And here we're going to see that now, if I refresh my page, I don't have this flash of style. But now, of course, this div here, I do not want to have it anymore after the first render. So all I have to do is do dimension.width is equal to 0. And if that's the case, then I want to return my div. And so what's happening here is I'm returning my div on the first render, while the state here, which has the dimensions of the window, is being set for the first time. And so basically I have a div that's going to cover that case, that first render. And so if I save that, you're going to see that now I don't have this problem anymore. And I can make sure also that this div won't exist in the DOM after the first render. And now the next step is to basically start drawing here a bunch of circles while the mouse is moving. And that's kind of what's happening here. We see like this painting effect, which is basically just a bunch of circles that are being drawn one after the other. I'm going to have a mouse event. So I'm going to do on mouse move on the canvas. And here I can have a manage mouse move function. And it's going to have an event as parameter, which comes from that event here on mouse move. And then I'm going to extract the client X and the client Y from that event. And so that's basically the position of the mouse. And so now every time I move my mouse, I'm going to call another function called a draw function that I'm just going to create after. And so I'm going to have here my draw function. And now let's see, this draw function is going to take a couple of parameters. The first thing that I absolutely need is an X and Y position, meaning where do I want to draw the thing that I want to draw? So X, Y. And then it's going to have a radius, because inside of that draw function, it's going to draw a circle. I can even call it draw circle so that it's a bit more clear. And so then I can draw my circle here, client X, client Y, and I can choose like a radius of maybe 50. And here, every time I want to draw a circle, I need to have access to my context. And I'm also going to change here the fill style just for fun. I'm going to put it red. So I'm going to draw a bunch of red circle. And so to draw a circle, I'm going to do context.arc. And so that's a function of the Canvas API. It requires a couple of parameters, the X and Y position, which is given here by the client X and client Y. It also needs a radius. So I'm just going to give it the radius coming from the parameters. And then the start angle is going to be 0. And the end angle is going to be 2 multiplied by math.pi. And we could go deeper behind the math of that, but let's not go there. And then I need to fill my arc after I've drawn it. So I can do context.fill, and I can just call that function like this. And here you can see that I'm actually drawing my circles. It's good, but I'm also seeing this weird shape. You see this like straight line that's happening. It's a bit weird. And the reason is the way the Canvas API works is it has a starting point and it draws everything from that starting point. Kind of if you would put your pen down on a paper and then you try to draw things from that point without being able to lift that pencil after you've put it on the canvas. And that's kind of what's happening here. And all we have to do to fix that problem is every time we draw a new circle, we want to lift the pencil, put it at the right position, and then draw the circle, lift the pencil, draw the circle, etc. Right? So for that, all we need to do is context.beginPath. All right, that's the function. And here you can see that I'm drawing a bunch of circles when I'm moving my mouse, which is nice. But obviously now I'm just drawing like red circles. How can I have this erasing effect, right? It's going to be really, really simple actually. All we have to do is use what we call in the Canvas API, the global, I believe, composite operation. Yeah, that's how we call it. And there's a bunch that you can choose, and it's basically a bit like the blend modes. Yeah, right. If you know the CSS blend modes, or in Photoshop, you have those blend modes. In Figma, you have them as well. It's a bit similar, the same concept, but applied to the Canvas API, and they have different names. So there's just a bunch of them that you can try. And here I'm going to see if there's like an example, a visual example. I'm going to take a look at another. Yeah, so that's basically what I'm looking for. You can see that the global composite operation, you can choose a bunch of them. And what we want to basically have that erasing effect is have the destination out. And so what it means is every overlapping shapes or overlapping pixels that we draw on the canvas, if 2 of them overlaps, it's gonna erase them. That's what it means. So I'm gonna grab that. And here, when I initialize my canvas, I'm gonna initialize it with also a global composite operation. And I can do equal to destination out like this. And let's see what we have. I'm going to refresh. And now you can see that I'm erasing my circles, right? Because I've drawn a rectangle at first, and that takes the full canvas. And then I'm drawing circles on top of it. And so they overlap. And since they overlap with the destination out, they erase themselves, right? So we have something like this, which is almost what we need. It's just not that smooth, but it's kind of the concept here. So really what's happening, if I move my mouse really slowly, it's actually working perfectly. But if I start to move my mouse a bit too fast, what's happening here is it's actually skipping some mouse move events. Since I'm moving my mouse so fast, it's not registering all like the positions between my mouse when it's moving, right? It's skipping some of them because I'm moving so fast. We can see here that we have drawn a bunch of different circles, but we have like dead space or empty space between each one of them, right? So the concept that I thought was to actually fill the space between two drawn circles with a bunch of other circles, right? And one thing to also understand is the faster I move my mouse, the bigger the space is going to be between each circle right now, right? So if I move my mouse slowly, not much space between each circle. And if I move my mouse like really fast, you're going to see that now there's a lot of space. By knowing that, what we can extract from the mouse move event is the movement X and the movement Y, which is the speed that we're currently moving the mouse. And here we could have a const speed. And here it's going to be the math max. Basically, which one is bigger, the movement X or the movement Y, right? So that's basically saying, give me the speed value. It's either on the Y axis, on the X axis. I don't really care. I just want to know how fast my mouse is moving. And also, you need to understand that the movement X and the movement Y can be positive and negative, right? Because it can go from right to left and left to right. And we don't really care for us if it's positive or negative for the speed. We only care about like the absolute value, right? So what we can simply do is math.abs of the movement X. So now it's just going to normalize it to a positive value, and then math.abs of movement Y. And here I'm just going to log the speed just to visualize a bit what's happening here. Here you're going to see if I don't move my mouse really fast, some really small numbers. And if I start moving really fast, now I get some higher numbers, right? Let's figure out how can we draw a bunch of circles between each circle. And so to do that, we absolutely need to store the previous position of the mouse, which would represent the previous circle that we've drawn. So that's going to be a must. So to do that, to store that value, I'm going to create a const previous position, and that's going to be equal to the useRef hook. So it's basically a reference. I could put that inside of a straight value, like just like this, but it's going to be reset. That value is going to be resetted every time the state changes, right? So that's why I use a ref, but it's not necessarily a must to use that for that specific animation, but it's still a good practice in a React-based application. So I'm going to have my useRef here. It's going to be an object. It's going to have an X and a Y value. And actually, instead of initializing them at 0 like I did for the window here, I'm going to initialize it at null. It's going to be a bit easier to see if we actually have a previous position or not. And then here, after I've drawn my circle, then I can set my previous position to X, the client X, and Y, the client Y. And so yeah, here's the linear interpolation. It's a function that I use a lot, and it's a function that you need to know if you want to make creative animation. Like, that's a must. And it's basically a mathematical function. You don't need to know this like by heart. It's like an equation that exists out there that you can reuse. You don't need to like know it. It's always the same structure. So what it does is it takes a current value. For example, here in this example, I have 10. It takes 10 and then it gives a target value. So I want to interpolate my current value to a target value. So in this case, I would like my current value of 10 to be closer to 0 here by 10%. That's what this means here. And so if I log this, it's going to be equal to 9, right? And then I could have value 10. I want it to be closer to 0 by 0.5, for example. So I want 10 to be closer to 0 by 50%. Then the value here is going to be 5. That's basically the linear interpolation. So I'm just going to grab it here, and I'm going to put it right there so I can actually use it. And so here, since I want to draw a bunch of circles between the position of two circles, what I'm going to do is based on the speed, because the faster I move my mouse, the more space there is. I'm going to create a for loop. And so little for loop here based on the speed. And so the faster we are, the more circles we're going to draw. So I'm going to put that inside of here. And now I want to draw a bunch of circles starting from the previous position, right? The previous circle, draw a bunch of circles to the current position that I'm in. So for that, I need to have like a little guard here, a little if, and check if I actually have a previous position. Because the first time I move my mouse, I won't have a previous position, right? So I need to check if I actually have a previous position. So if it's not equal to null, then I'm going to go inside of that code. And so now to draw a bunch of circles between two circles, I need to have a target X, which is going to be equal to my linear interpolation. And here is going to grab the previous position.x, and I want to interpolate it towards the current position of the mouse. And then I need to give it a value. So by how much do we want our circle to be closer to our current position from the previous position? I hope that makes sense. And for now, we're just going to do 1. So it's going to be at the exact same position. This would be really useless, but let's not go too far so it doesn't get too complex. Now I'm going to copy paste that. But now for the y-axis, something like this. And then I'm going to draw a circle on the x and not the y. Just going to do this so it's a bit simple, and I'm going to take a look at the result. Okay, so here nothing is happening. I think the problem is here I need to specify the current. So to make this a bit more clean, I'm going to do x, y. I'm just going to extract those values from the previous position dot current. And so here I have x, y like this. Let's try this out. This should be the same result that we had before because we're putting a 1 as a value for the linear interpolation. So we're basically saying the target x is going to be the x closer to the current position by 100%. So it should be the same thing that we had before. Let's see. Yeah, same problem that we had before. And so to fill those gaps, I need to have a slowly increasing amount here, which is going to create all the circles between the space, right? So it could be 0.1 at first, and then 0.2, 0.3, 0.4. It's going to draw a bunch of different circles at different position, right? And that value here is going to depend on the speed. And here I'm going to change the name speed to have something that represents a bit more what's happening here. And it's simply the number of circle that we want to draw. And so here, depending on the number of circles, it's going to set the amount here that we want to interpolate to. So it's going to be 1 divided by the number of circles that we have multiplied by the index. It's going to be the same thing on the x and y axis. And so I'm going to save that, and let's try this out. And now you can see that the painting is actually much smoother. And even if I move my mouse really fast, it's super smooth. And that's because I'm drawing a bunch of circles in between each circle that I'm drawing. And so right now there's a lot of draw circles function being called. And so I'm going to try to optimize things a bit, and I'm going to reduce the number of circles here. I'm going to reduce them by maybe like 30, let's say. So I'm going to draw actually a much less amount of circles here. Let's see what we have. And here you can see that I still have the problem that we had before, but a bit less worse, but I still have it, right? You see like it's not really smooth. And if I do like 50, it's going to be even worse. And so you see here that it's drawing a bunch of circles between each circle that I'm drawing, but still it's not enough circles for it to create this smooth effect. And so I'm going to reduce that, I think, to 15. And 15 is the right, and I think, no, 15 is still not enough. I still see some little, not smooth enough. So I'm going to do 10. And yeah, now it's pretty smooth. And honestly, dividing this by 10 is the right value that I found for a 50 of radius to basically not draw too many circles, but still have like this really smooth painting effect. With that, we have this final animation, a nice painting effect, which is really useful to know. And it's actually quite a nice like storytelling type of animation that I've used in some of my contracts, and some clients really like it because it has this like revealing effect. So depending on the message that you're trying to convey in your design, it's actually a really useful animation. So yeah, that was it for this tutorial. I hope you liked it. I hope you learned something, and I'll see you in the next one. Bye.